everybody. Today we went over heat transfer. If you remember from the last time we were together, we talked about temperature and we practiced reading temperature scales. So if you didn't finish your practice of those 6 temperature scales, finish that up and then you can check your answers against my key. Okay. For your heat transfer notes, here's the file if you have access to a working printer. If not, you can just sketch this diagram in your science notebook. Right? And then of course the filled in version is here in my science notebook, so I would go ahead and copy this and then listen to the rest, which will be the explanation of the notes. So I'd do that first. Alright, so here's the notes. Okay, so heat transfer, right? So we kind of use the word heat incorrectly, right? We say heat when what we really mean is thermal energy, right? And thermal energy is just how fast those little particles are moving. Like in a solid, they're not moving very fast. And then in a liquid, they're moving a little faster. And then in a gas, they're moving even faster. So that's all that this thermal energy is the moving or the kinetic energy of the particles of matter, right? So when we talk about heat, it's the transfer of that thermal energy. And that happens in 3 ways. Okay? And having just been on the planet for about 11 years, you've encountered multiple examples of each of these. So if you want, you can add examples next to the notes just to help you out. Let me focus in on each one. So up first, obviously this is a pot on a stove. Looks like a natural gas stove. Maybe at home you have a flat top surface or the kind with coils. Okay, those are going to be conduction, just like this. But if you've got the natural gas with the blue flame, that's going to be radiation. Okay, so this one's just a natural gas stove, so maybe you've seen that before. Okay, conduction, the way I remember it, like a conductor with the wand, doing the symphony or the band, they're holding that stick in their hand. Okay, they are the conductor. They're holding something, or we say that conduction happens through direct contact. All right, or a less fancy way of saying that is by touch, especially with solids, right? Because all the molecules are so close together, right? And with solids, especially with metals. Okay, when we get into chemistry and talk about metals, nonmetals, and metalloids, we'll understand a little bit better why metals versus nonmetals. But even like the spoon here, if you've ever helped cook, you know that the spoon, if it's going to stay, let's just say this is soup, if it's going to stay here, I sure hope that's not a metal spoon, because if you grab it, you're going to burn your hand, right? Or maybe it's metal at the scoop part, but on the handle it's a rubber or a plastic, because we know that metal is a good conductor. See how that goes together, conductor, conduction? Or maybe this is a wood spoon. So wood and plastic and rubber we know as insulators, which is the opposite of conduction, or it just doesn't conduct very well, right? So that's one way thermal energy is transferred, is through direct contact or touch. Okay. But if we scoot over, all right, then we look at convection. All right, some people have a convection oven. This happens more than you necessarily realize. Okay, if you live in a 2-story house, you know how it's always hotter upstairs, right? Or think about a hot air balloon. What happens to hot air? It rises. Okay, this plays in with density. Now, you did a lot of will it float or will it sink in elementary school, and that's just with water though. Okay, so think like the hot air balloon, that's in the air. Think about things as far as gases go with density, like helium in balloons. If you let go of that string, your balloon's gone, right? Versus something like carbon dioxide. Okay, think about like the haunted houses, all that kind of smoke and stuff along the ground is really carbon dioxide gas, but it stays on the ground because it's more dense. Okay, dense things sink, less dense things rise up. So let's say this is soup, right? The bottom part's getting heated up, so the molecules are moving faster, because remember that's what temperature is the average of how fast those molecules are moving. And so it starts moving around faster, and it will become less dense and rise up to the surface. When it hits this cool air, it'll give that air some of its thermal energy, and it'll cool back down, making this circular pattern called a convection current. Okay, convection current. So think about if you're making macaroni and cheese and your water is boiling with the macaronis in it, it's kind of like dancing in the pot. That's because of this circular pattern. This also happens in the ocean, and if you add that in with the ocean water getting warmed up by the sun all day, and then giving that heat to the air, coming back down to the depths of the sea that doesn't have sunlight warming it up, plus the earth is spinning, that's how you get those currents in the ocean. Think about like that ships sail through, or channel a Finding Nemo memory, a little Crush the turtle going through the East Australian current. That's because of this process happening in the ocean. It also happens in the air, like the wind patterns we see, right? The land heats up, and depending on during the day or during the night, we can create land breezes and sea breezes near the coast. So if you stand on the beach, say next time, go on a vacation, during the morning, the wind's blowing one way. And in the evening, it's going the opposite way because of this pattern between how much the land, or like the beach, absorbs the temperature or the heat from the sun, and how much the water does. If you've never been to the beach, think about a swimming pool. All right, in the middle of July, in the blazing heat, the water still feels cool compared to the cement that you walk on outside the pool, right? But in the evening, the water may feel warm compared to the cool cement or the cool breeze outside. Okay, so later in science, we'll talk about specific heat capacity, like how much energy things can absorb and how fast. Right? So that's for another time. But this process, the circular pattern, is obviously called convection current. So convection is the heat transfer method. This time it happens through the motion of particles in fluids. All right, so when you hear fluids, it's typically when they say drink lots of fluids, like when you're sick. Well, liquids are fluids, but in science, so are gases. Like there's a whole branch of engineering that has to do with fluid dynamics. So think about every fast plane, car, ship. Think about the sleek design. That's so the liquid or the gas can flow over it smoothly. All right, so gases and liquids kind of behave the same. So in science, we call them fluids. Right? So just kind of get used to that. That leaves us with radiation. Most of us, when they hear this, have like a negative connotation of it because we think of it in terms of like getting cancer or a treatment of cancer. There's radiation in lots of forms. In 8th grade, you'll go more into detail about this electromagnetic spectrum, right? But it can be something as simple as the radio waves going through right now. They don't hurt you. They're not dangerous. You can't pick them up as a human, but the machine that turns them into music can. Okay? But as in terms of radiation, it's anything that's traveling through waves. For example, the sun. The sun warms the earth. We don't have to touch the sun. All right, the sun is super far away, but the warmth makes it to us through empty space. And it does that traveling as this kind of wave. All right, so think about the sun. Think about things like infrared, like, think night vision goggles when it pick up on body heat, or even like the fry warmer at McDonald's. It keeps the fries warm, right? That reddish kind of lamp. Okay, that would be radiation. Microwaves. When you put something in the microwave and heat it up, the whole job of this microwave is to use microwaves, hence the name, to excite the little molecules in your food. So like the water, the fat, the sugar, it makes those wiggle around and dance, increasing their temperature, was just the whole point of putting it in the microwave. Maybe you put a plate of food in and not everything was the same temperature when it came out. It has to do with the content of water, sugar, and fat of the food. Okay, so this kind of stuff is radiation. Like I said, you'll learn more about it in 8th grade in a bit more detail, but really ask yourself, like with radiation, do you have to touch the thing? Mm-mm. Is it a liquid or gas? Mm-mm. Like a campfire, you just sit near it, but you're not touching the campfire. That would be a bad choice. Nor is it liquids or gas. Okay? So you'll be able to, in any situation, decide which of these three types of heat transfer it is. But know that in any given situation, multiple ones can be happening at the same time, just like with this pot on the stove. You've got all three happening simultaneously, and that's normal. Okay? Even in different places, like if I touch this, okay, depending on what the handle is made out of, where the pot is touching this, well, we'll say this part. Let's say yours isn't radiation. Let's say yours is one of the coils on top, where the pot touches the coils. That would also be conduction. Okay, so just kind of keep that in mind. So you've got this. When you're done, oh, close my windows. When you're done, you're going to do the EduSmart heat transfer. Okay, so EduSmart doesn't talk to Google Classroom. So you go to Launchpad, right? Go to find the science folder and click EduSmart. Okay, so I'll show you. Mine looks a little different, but you're on Launchpad. There's a science folder. Within science, you're looking for EduSmart. It's a little blue guy with the E for a head, kind of rocking a Hamilton pose. Okay, when you click on that, you'll see the heat transfer assignment. So there's a couple little, they call them instruction modules. They're like little videos. And then you'll have a simulation, kind of like an online lab, and then a practice quiz. Okay, so handle that. If you have any questions, send me an email or ask me in class. Thanks.